Hi and welcome to this section where we would like to look at correlation. So under correlation, one is interested in measuring the strength, okay, and the direction of the linear relationship between two variables. So I have some examples here, which is on a certain web page here, which I found, which was quite nice. So yeah, maybe you can take some time. You take some time also, and you can visit that site. You can pause a little bit, and then you can maybe punch that into your browser, so that you can access this this content here, which was quite nice. So I won't go through this. I think you can read on your own, but I explained, I think, some of those. Well, the examples I wanted to show are some of, because we are talking about the strength and the relationship, okay? The strength and the direction of the relationship. So, okay, a few important things to note here. They say that the relationship has no correlation when the points on a scatter plot do not show any pattern. So in the previous lecture, we plotted our scatter point or a scatter plot in MATLAB. So you have an idea what this is. So when they say that if there is no correlation, then the points do not show any particular pattern. And then a relationship is linear when the points on a scatter plot follow a pattern but not a straight line, okay? And then, it is non-linear. It is non-linear when they follow a pattern but it is not necessarily straight. And then it is linear when the points on the scatter plot follow a somewhat straight line, okay? So we are interested in this because we are looking at our linear regression, simple linear regression and correlation. So we are interested in this one here where the relationship is linear and the points are showing somewhat a straight line, okay? So this can either be positive or negative, okay? Positive relationships are points that incline upwards to the right, i.e. with a positive slope. So we can see that if we are to draw a line to kind of fit this data and also try to minimize, the errors, i.e. the distance from each of the points to the line here, by drawing our line of best fit there, we shall see that the line here is positively sloped, so we have a positive relationship in there. Clearly here you can see that we shall have a negative relationship because the slope here is going to be negative, alright? And then this is non-linear, clearly, because you can see that our data will increase, and then somehow either it reaches and then it is kind of flat at the top here, okay? Or in here it is hard. I'm not so sure if you can find any relationship in here, okay? So so we have no relationship. Yeah, we have no relationship here. I'll explain this later on in our notes. I'm not interested in that. I was simply interested in showing you these examples. It don't make sense for me to write these when I can clearly just come in the web page here and show you. So here you can see also these other examples. Here you have now we have terms here. I shall come to this. Okay, let me talk about this, then we get back to our notes. So we have what we call here a strong positive relationship, okay? Here, this is the R is the correlation coefficient, which we're going to talk about in a minute after here. And then we have a moderate positive relationship. It is positive here, but it's strong. Here it is positive and it is moderate based on the value of R, which I'll explain in a bit. And here it is strong based on the value of R, which is 0.96. And then this is positive. Yeah, somehow you can see positive, but very weak based on the value of R. And then the rest here is just the opposite. This is negative, very strong. This is moderately strong, and then this is a very weak negative relationship, okay? All right, so this is very important. I think I also noted it, so I'm going to get back to it in a minute. That when we're talking about correlation, we are not interested in causal effects. In other words, just because two variables are correlated, you see some relationship, it does not necessarily mean that one variable, okay, causes the other variable to change, right? Okay. So yeah, so I was interested in some of those examples, because we said the strength and the direction. So we have seen here, we have talked about the strength, we talked about strong, moderate and weak. Okay, we talked about here strong, moderate or weak. And then in the direction here, we either had the positive or we had the negative. Okay, and then this here was based on the values of R, which R is this one here, which is called the sample correlation coefficient, and that is R, the sample correlation coefficient. So the sample correlation coefficient is R, we denote it by R, and then the population correlation coefficient, we denote it by rho. So these measure the strength of the association. So that is why we are saying that it is either strong, moderate or weak based on the value of R. It is measuring the strength of the association here. And then the sample correlation coefficient is simply estimates the population correlation coefficient. Okay. Of course, we cannot get data for the whole population. We always deal with samples, and that is why we are interested in R and not rho. It's kind of useless for you to find rho. I don't know if that is possible anyway. So the characteristic of either rho or R is that one, it's a dimensionless number, and then two, the value ranges between 1, positive 1 and negative 1. So the closer it is to 1, then the stronger the relationship, okay, another positive relationship. And then the closer it is to negative 1, then that is a strong negative relationship. And then the closer it is to 0, then we have a weak relationship. Okay, so somehow in the middle, that is what we are talking about, moderate. And then the closer it is to the 0, then we talk about the weak. Okay, so what else here? Okay, now how do we calculate this sample correlation coefficient? Well, have the formula here. Okay, we are not just interested in the derivation, and the formula, if we have simply x and y, okay, our data here, the x and y, then we can just calculate R by getting this formula here, the summation of x minus x bar. X bar is the sample mean, okay, y bar is also the sample mean for y values. This is the sample mean for the x values. So you simply get x minus x bar and then y minus y bar divided by the square root of x minus x bar squared, the summation of x minus x bar squared, and then here the summation of y minus y bar squared. Please note the difference. That's the summation of x minus x bar squared is very different from when someone writes x minus x bar then everything squared. Okay, so I would like you to note that we are saying it is the summation of the square of the difference between x and x bar. Here it is the summation of the square of the difference between y and y bar. So alternatively, if you do not want to use x bar and y bar, then you can use this other formula here. You can try it, it will give you the same value. So we are going to try this out using the data set that we had last time. So ideally, if you're maybe using this and you're computing this by hand, then you shall have maybe a table, a column for x values, y values. Of course, from x values you can compute your x bar, you have it, and then you have your y bar, you have it, Then maybe you can have a column of x minus x bar, and then you can have x minus x bar squared, and then you have y minus y bar, and then you have y minus y bar, everything squared. Okay, so you have such a table. And then you just begin. You have x, you have that, then you compute, you have your column values, you get the mean of these, and then you keep on subtracting the mean from each individual value you place there, and so on. You can fill that, then you square each element here, and then you do the same here, and so on. And then then at the end you begin summing up all the things that you need to sum up. Okay, so you just add them, not adding them per se, but then you just come and compile them and place them in this formula here. I'm very sure by now, students of engineering in year 2, this should be a piece of cake for you to do. So we are not going to do this by hand, but I suppose you have to learn also how to do it simple by hand, because if I ask you by hand, it's just to make sure that you understand the what? You understand the idea, okay? It's not anything rigorous. I can just give you like a small data set of maybe 5 points and so on, so you can compute and so on. So what we are going to do here, I will go to the MATLAB and then we will compute this. Well, I am going to, ideally, okay, let's say compute the correlation coefficient using this formula, but to save time, I will just punch everything in MATLAB. So let's go to our MATLAB here and then see what we want to do. So we have our data set, the one we used last time for the regression. This is it. We have the values of x, and then we have the values of y. Maybe let me say just a minute. So we have x and then we have y. Yeah, I already extracted them. I have them in the workspace here. So just for the purposes of showing you what to do, then please, maybe it's advisable that you first write down the formula, okay? Then you can see what we are going to do. So I'm going to get, I am going to, just a minute, how do I highlight? I get the highlight here, this, and then maybe I can use a yellow. Okay, so I am going to get this value x bar, then I get y bar, then we compute x minus x bar, and then we compute y minus y bar. After that, we square that here, and then we also square that, and then the rest is just plugging in into the formula. So have this formula written down as we go to the next screen. You can pause and then write down the formula, and then you follow from what we are doing in the MATLAB here. So we shall say that x bar is going to be okay, yeah, we shall first do that, then we shall, maybe before we compute this, let us do this. Let us just first find the correlation coefficient directly from MATLAB, okay? We can do this using the command, I think it is it is correlation coefficient here, and then for our values we had x and then we had y, okay? So what do we do? Yes, so well, it gives us here matrix. Okay, maybe what you have to know here is that when we do that in MATLAB, it's going to give us a matrix, and the meaning of that matrix is the following. Okay, is the following. So we have values of x, and then we have values of y, and then we have here x, and then we have here y. So now essentially what is in the matrix here, the value here, it gives us the correlation coefficient of x, and then this is x and y, and then this is y and x, and then this is y and y. So ideally the correlation between y and y is 1, okay, and then the correlation between x and x is 1. So the answer here should be the same as the answer here. Okay, it is the same. I think I'm not so good at the statistics here, but I think the correlation between x and y is the same as between y and x. If I've said something wrong, you can please put it in the comments, and yeah, you can teach me a bit of statistics here. So that is ideally what we have. This is x and x, then this is x and this is x and x, then this is y and y, then this is the correlation between x and y, and then this is the correlation between y and x. Okay. So yes, the correlation coefficient between x and y is this one here, negative 0.3395. And indeed, when we had our scatter plot here, okay, in our MATLAB here, when we had our scatter plot, we can see that we had a negative slope here. Okay, the correlation is weak negative relationship here. Okay, so what were I trying to do here? Okay, that is it. That is the value. So whatever computation we are going to get, we have to be within that limit here. It has to be around that. Okay. So next, we said in our computation formula we are interested in x bar, which we know is the mean of the column x. Okay, so we have our x bar as that, and then in the similar way we are interested in finding y bar. So we shall call that y bar, and then we can compute it, and then we get that. Okay. So what else? We have a column which we are going to call A, okay, and that is x minus x bar. Okay, you see that in the formula. So we have x minus x bar. So please note that x is x here is a vector of 31 rows and 1 column. Okay, it is a what do they call that? A column vector. But then x bar is simply the mean, which is scalar 7.66. But in MATLAB here, if you get a vector then minus a scalar, it is going to subtract this scalar from each and every value in the vector. Therefore, the result of x minus x bar is also our column vector. And indeed, we can see here A is a column vector of 34 rows. Sorry. And then we also want to find the value of B, okay, which we are going to call y minus y bar. Okay, y minus y bar. Okay, and then I'll just put the semicolon there to suppress the output there. So we have also B. Okay, that is, you can check here, and then you see that the B is also a column vector. So what else are we interested in? We have x minus x bar then squared. Okay, so but x minus x bar, we called it A, so we can call this one A squared. Okay, ideally, which someone would say is going to be equal to x minus x bar squared, which is the same as A squared. So let us try this. Okay, we can put A, then we can put squared. So we have a problem here. So in MATLAB, remember that if you put a squared, then it is going to get these matrices and then try to multiply, because the column vector is ideally also a matrix. So it will try to get that column vector and then multiply with the column vector. But you know, a column vector 34 by 1, you cannot multiply it with a 34 by 1. They are not compatible. Okay, but what we are interested in here, by the way, is not matrix multiplication. We are interested in element-wise. Okay, in other words, when we say x minus x bar squared, we want each entry in that x minus x bar to square it. Maybe let us go back here. So here, when we have our table here of x minus x bar, if x minus x bar here, the value is 4 and the value here is -1, then x minus x bar is the 16, and then we square this and then we get 1. In other words, it is element by element, you know. The operation is done on element-wise, and that in MATLAB is done by that. You just put the dot here, it will mean element-wise, okay? And then that should also give us a vector, okay? A square. You can come and check here is vector. A square is also a vector there. So similarly, you can do the same with b, that is y minus y bar squared, but y minus y bar, we said it's b, therefore we can call this one here b squared, and then this is going to be b, and then element wise you do that, and then we square that. Please mind you, it's just that I'm lazy to work these things by hand, but ideally this is what you'll be filling in your column vectors, okay, filling in your table. So that is b, and I think we are done. Yes, because we have everything we need. So I'll just say that our correlation coefficient R here is simply going to be the sum of x minus x bar times y minus y bar. So we are going to have the sum. What is x minus x bar? We say it is a, and then times y minus y bar, which we call b. No, this is also going to be, remember we want this, okay, I think we have to get that. Let us call that AB, okay, we want to get is x minus x bar times y minus y bar, which is going to be a, again it is going to be element wise, okay, element wise times b, because I want each entry in the column x minus x bar, then I multiply it times the corresponding entry in y minus y bar. So that is why we do that, okay? So yes, then we do that, and then AB, you can come and check here that AB is also a column vector here. Okay, so now what we want to do is that we are going to say that R is going to be equal to the sum of AB, okay? So we are going to say the sum of our AB. Our AB, remember, is x minus x bar times y minus y bar. Then everything we are going to divide by the square root. How do they do square root? And then what do we have there? We have the sum of x minus x bar then squared. What did we call that? X minus x bar then squared. We call that one a square. It's this one here, not so? This one here, which is a square. So here we simply put in a square, and then it is times b squared, not so? Yes, times the sum of y minus y bar squared, which we actually also call b squared. So if I haven't made any mistake here, especially with the parentheses, then I think we're good to go. Let me just check that they balance out well. Okay, that's okay. Good. And we have the value of negative 0.335, which we also got directly when we just used the formula if we are just to purchase the correlation coefficient. So this, okay, and that. So ideally this is what we've got using our computation, using the formula, and then this would be what MATLAB simply, this is what we get using our formula, and then this is simply what MATLAB gives us when we use its command to find the correlation coefficient. So you can also try this. I don't know, you can have time, and then you can also just compute this the formula here. You can use also this one here. Okay, you do it exactly the same way. You just find your columns and know which columns to use. Maybe x, then y, then xy. What else? Then you have x squared, you have y squared, and then the rest are the summations, and then you just punch the values in there. So you can try practicing that by hand, only that there are 34 entries. I don't know. So, or you can get a small data set which you can use. Okay, maybe a few things I really didn't talk about here because I didn't want to take a lot of time is that in this table here, which I had and I had just saved in the workspace here. It contained some values which were not numerical, so I don't know. Anyway, if you encounter any problem, you can always ask here and there. But if you import some of these values, if you just import some of these, you may find that some values are not numerical, and then MATLAB may give you some issues if you have anything in your matrix, or if it was a table which is not numerical. So that is it with our correlation. So I'll try to give you what it means intuitively, and then how to compute it, and then we can also just use these commands directly, and so on. So I hope you have appreciated some of this and learned a thing or two. So if you have any questions, you can put them in the comments. Okay, so thank you, and see you next